Good morning and good evening, Arya. This is Sirisha. Today I'm going to take a session on the code optimization measurements. How will you take the code is optimized or not? How will you know that? So this should be little bit interactive, and whatever the knowledge I have, I want to share with you. Maybe it is little, but I want to share with you. So when you write a code, how will you measure your code is optimized? Can anybody tell me how you will measure with it? You have written a code and optimized it. How will you know code is optimized better than the previous one? Can anybody?
I imagine there are some tools that you can use to see optimization, for example.
Okay. We can use sonar, isn't it? We can use cognitive complexity, cyclomatic complexity.
Okay.
Yeah, apart from those tools, we can even check the performance also. We can check how many seconds.
Yeah, we will have some knowledge that this much time it is taking. Now I reduce something. This much space I am taking. This much rate. So we have with optimization we came to know that I have reduced this much. So how will you measure that? Means how will you know that time is reduced, space is reduced with your optimization code? So today's my session is on that only. How will you measure that complexity, time and space complexity in your block of code? If you take a 4-5 lines or a function, how will you measure the time complex, space complex? So what do you mean by time complexity? Anybody have idea on that? I know you all know because you are the developers, I know. So our next slide is why we need to know a time complexity and space complexity. So for code optimization measurements, we will do with the time complexity and space complexity. Means how much time it is taking to run that block of code and how much space it is taking to run that block of code. So even if any code is taking less time, but input is small, it is taking less time. It does not mean that code is optimized. You have to check for the code, how it behaves when the big inputs or large inputs are given, how it behaves. That is the where time complexity, space complexity comes into picture. So for small inputs, it will not be much visible for you for the optimization. So time complexity and space complexity related to the optimization techniques. So to compare two algorithms for the optimization, we have to know the complexity of the time and space. So large inputs only we have to compare. Small inputs every time it will run fastly, but we have to check for large inputs how your code behaves when you run that. So more on I am stressing on the large inputs. Why? Because you may think for small 10 number of 10 iterations, this is not the way to check your code optimization. So that's why I'm stressing on the large inputs. So time complexity refers to time to compare two algorithms. We use time complexity and space complexity. So we have to make this complexity based on the large inputs. So why we need is to compare the algorithms for the optimization. So next, so in time complexity, space complexity measurement, we have one big O notation which is recommended by them. So big O notation means how to measure a complexity. We will use this one. So here it says three main points. That is, iterations are the space should be on the input size, and we have to always take the older terms. Older terms means, for example, I given. So in your code, you have 3-4 iterations are there. One is taking number of iterations as n square, means 2 for loops are there. One is taking 1 for loop only n times. So you have to consider the time complexity as a n square. So you have to consider higher order terms, which is having the larger will be taken as a complexity. So constants, and this 6 is the constant. We will ignore that. This is the big O notation to calculate the time complexity and space complexity, which is used widely in everywhere. So with this slide, what I mean to say is we have to calculate with the input size, and we have to take the higher order terms, and we have to ignore the constant coefficients when you are measuring the time complexity and space complexity. This is a note. notation given by everybody using this just for calculating this time complexity. So this big O notation we will use in the next slides. So as you know, what is time complexity? So what do you think time complexity means? What I explained just now. This is the amount of time it takes to run your algorithm, means your block of code or your function. So how much time it is taking. So running time increases when the input size grows. So when small inputs are given, it may take less time. But when the input grows, how your algorithm is taking the time complexity that you need to measure, and that is known as time complexity for that. So, for example, give me a simple example I will give you. How will you calculate a factors of a number? I given a number. How will you calculate factors? Brute force approach. Give me that one. Anybody? You want to calculate it? I given a number 12n. How will you calculate a factors of it? 12. Anybody? Hello? Am I audible?
Yes,
you are.
Yes. I mean,
So,
one is a brute force approach, right? And
yeah.
we can use this the slider approach as well. We can use that.
Yes. Yeah. So you have. So normally means initial stages are somewhere. If we have to find the counters of factors, we will use brute force approach maximum. What is the logic we come into our mind, we will use. So we will loop through the till the n means 12, and we will calculate whether it is divided by I, then if it is 0, then factors. We are counting on the factors. This loop, if you measure with the time complexity, this is n times it is looping. So this complexity is order of n. So this way, this time complexity is order of n. So do we have any approach to reduce the time complexity? So if it is increases to means next slide I will explain. If it increases 12 is minimum, so it will execute 12 iterations is a normal thing. If I given more means big number, so that many times it is iterating means it is taking a lot of time. So big inputs we need to calculate this approach. So one of the things you have to code optimization is the observation. So observe the logic, how the logic can be reduced to reduce the time complexity. So next slide I will show you. So how when input grows, so factors I have given. When I given n as some lakhs of numbers, how the performance increase. So assumption I am taking, if size is 10 to the power of 8 takes 1 second, means 10 to the power of 8 number I have given, it is taking 1 second. So 10 to the power of 8 iteration, it is 1 second. Then if 10 to the power of 9 number I have given, it is taking how much time? It is taking 317 years for calculating the factors. So this is a very long time. If you give a big numbers, it is a very long time for you to calculate when it is 10 to the power of 18. Okay. So means your code is not optimized for the big input size. So what you have to do? You have to observe what is the logic I can reduce to the time complexity. So next slide I will give you. So this is observation only. So I'm giving simple example. In normal ways, you can also have the dry runs and observations, and you can reduce it. So if you take 10 as a number, so factors you have encountered 1, 2, 5, 10. Here 1 into 10 is 10. So when you are dividing it with 1 as a factor, you are getting 10. So 10 is also factor. So when you are doing this one, if n is equals 0, we are incrementing it plus 2. And we are optimize the code to iteration as half of the iterations. You see, I into I less than or equals. The iteration is reduced to half. Okay. So reduced to half means then 10 to the power of 19, then iteration will be 10 to the power of 9 it will become. So previous slide, if you go to previous slide, 10 to the power of 18, how much it took? 317 years. Now 10 to the power of 18 or 19 something. So 10 to the power of 9 it will become half the iteration. So time complexity is reduced to 10 seconds. Previously it is 317 years. Now it is reduced to 10 seconds. So how you did it? Because of observation. So always code will be done with the observation. How I can optimize the code to reduce the time complexity. This is a simple example I am giving. So with reducing half of the iteration, we got the time complexity to lesser and lesser size. So this is the way to improve the time complexity. So you got idea on time complexity, I think. So is there any?
Yeah.
Yeah. So only thing, so I stress on the bigger inputs and the observation. So don't take your code as it granted for smaller inputs. Only go for the bigger inputs and check your code, and also do the observation of your logic with dry runs, and take the whatever the things logic you can modify and reduce the times. So that is the time complexity improvement. Next comes the space complexity. So as you know, space complexity refers to amount of space it is used by the algorithm. So whenever you are writing a code, so always think that space should be utilized minimum. So if you have given a case that input is not modified, if you have given an array as an input to your method or something, if unless and until it is said that you don't modify the input, you can use that input only, so that it space cannot be increased. So if they have mentioned you can modify the input or anything we can modify, then you use the same space as it is occupies. So that is the way we can reduce the. So always think that how much space you are increasing. Are you using any unused variables, unused arrays, unused data structures? Don't use that. It will acquire the amount of space. It will kill, but the code running time, it will occupy the space. So always consider the space complexity. When it becomes bigger input, space complexity, if you take the arrays or data structures, if it is a big ones, then space will be increased. If you declare another with the copy of that one, then the space will become twice. So that will create the slowness in your code running. So always consider the space amount of space that your code is using by variables or by arrays or data structures. So that is what you have to consider for the code optimization. So in worst case at any point, so worst case scenario you have to remember. Worst case, how much big space it is occupying. Don't think on the edge, means normal cases it is taking this much only. Don't think that. So you take the bigger size and how it will occupy the space you have to calculate. So when the input size goes, as I told in the time complexity, input size is the main factors for the calculation of time complexity and space count. So algorithm also increases its space consumption. So this is space complexity. So for example, if you have this one, so how to calculate the space complexity if you have a function called sum. So we have three variables. If you discard the input variables, then only consider the code whatever the variables you declared this one. I have considered input variables also. So it's a 4 bytes, and long is 8 bytes, 16 bytes it is 10. So big O notation is always ignore the constant coefficient. So it is the order of one term. So sum is occupying order of one term. This is okay. So calculating the space is number of bytes or number of that space it occupies, that tells the space complexity. Here this sum function is occupying only order of one space complexity. So when you go to little bit more, so you have declared, you have some function where you, yeah.
I have a question. Can you go back to the previous slide?
Yeah.
So how you are deciding here it is a order of one?
So I told you in big O notation. Here, ignore constant coefficient. If it is a constant, then you have to take an order of 1 only, because there is no n array or something. So it is only all are constants only. So if it is a constant, we will take the constant coefficient only. So this is all are constants only, 4, 4, 4. We will take as a order of 1 only.
Okay.
Okay. So here, if you take, so it is 4 bytes, and it is 8 bytes, and I have declared a list or array something. I am pushing a data for n iteration. So it is a long, so 8 bytes into n, 8 star n. So we are this space complexity is order of n. So what we are ignoring with the big word notation, we are ignoring the constants and we are taking the larger term. So order of n terms is the space complexity of this method. So if input size grows, this size also grows. So if you have the input of list only and you are declaring again an input, then it is becomes the double the size. So if permits, if you have any input with the array or something, then you utilize the same time complex, same space only. So unless you require, you declare the variable or arrays or data structures mainly takes the space more. Heaps and trees, everything will take the more space. So you have to consider before declaring anything or before declaring any arrays, space complete. Are you declaring duplicate ones? Are you declaring unnecessary things? Anyway, for code optimization, I know you think unused variable should not be used, that we should be remove that one, and unnecessary declaration of variables also not necessary. So small inputs when you are running, it will not create problem. But as I said, sorry. So goes on, it will increase the space. So you have to code should be optimized to acquire only minimum amount of space, which if it is required, okay, but if not required, you can optimize for the space complexity also. So this is for the space complexity. I have little only, so. So this is it. I want to share the time complexity and space complexity measurement and what is the optimization you can do for the time complexity and space complexity. This is the knowledge I have. I shared with you. If you have any questions, please. Maybe I rushed it very fast, I think.
Any questions, anyone?
From my side. Is there any anything we can use to measure this, or this is only for using observation only we need to do this?
Mainly means logic only tool will measure. I don't know knowledge about tool, but tool which will measure only the how much optimized your code is, but it will not give the logic how you implement that one. That will be done by the observation only. Tool will only give the what is the code you have. Code is having the optimized code or not, it will give. But to write or something you have to do for the optimization, you have to observation only you have to do. But tool will help you to tool will help you to know the time.
I think SonarQube we can use for the same purpose, right?
Yeah. SonarQube will give the. It will give the code component. I don't have much idea, but
SonarQube will give.
Yeah, I mean, it will give it will provide more details about the code complexity. Like mainly, like it will help us to write the code in a better way. Like if a particular method has like a multiple many business logics in a single method or single class, so it will provide the cognitive complexity, which mentions that how many conditions do we have in that method. So with that, like we have to reduce, like generally the Sonar administrator would define the number, and if the particular method crosses the particular number, it would kind of show some kind of bug or some error. So generally, like what we do is we move some part of the code from that method to other method, and so with that, like the code complexity or the cognitive complexity would reduce. So that's how we write using the Sonar build or Sonar scanner, we write the code in a better way.
So that will give the code complexity. I think space, how much space, these things will be there. Means I have seen it, but
No, these
I
things
am
will
not
not
sure.
be there.
These
No, the
things will
space
not be
and
there, I think so.
yeah,
The
that will not
space,
be.
yes, space and time, I don't think is.
Yeah, it will
Yeah.
give the code
More of
complexity, how
optimization.
much,
Yeah, it was
more
more
of the
of
code
optimization.
optimization things, but it will not give the how much time or how much this is taking for you, means how much optimized it is for, it will not tell, I think. Code complexity it will give.
Yeah,
These,
absolutely.
I think time and space complexity is more on like our individual, like what you said, observe.
Yeah, observation.
How we
That's
observe,
why
how we calculate the performance. Yeah, these things depend on it.
anyway we can have a means we can research and have another session on that. If
Sure.
we found any tools of that sort, then we can use that one if we want to have it. But main purpose, observation is the main thing. I have I have observed that this is the observation is the main thing which will give us the logic to be optimized, algorithm to be optimized. So as you said, sliding, something you said, factors, and these things are the observation only we can know that. So this can be done like this can be done like this. So more into data structure algorithms, this will go into that type of things, logical things.
Yeah.
Yes.
So I have a question, guys, and how can we know that we are like our code is fully optimized? For example, if you have 3 different scenarios and you start writing your code, so once you finish your code, you're going to make those calculations in order to see the observations and know how the time complexity and space complexity is. So, okay, after the first revision, you realize that you need to optimize the code. So, okay, you go and optimize it. Then you make another, again, the calculations. So how can we know that this is like the result that is expected on the refactor of the code? Or if I need to do like another iteration, if I can just optimize more? So is there like a measure or some values, some ranges that we can use to do that?
Actually, if you come to means anyone can answer that, but what I feel is if you are in the iteration, if you reduce that iteration means that is nothing but reducing the time complexity. I feel so. So you have previously you know that it is like I shown you previously you know that this many, if you give any number and it is having this much iteration, if you reduce that to half or something by seeing code only, I think you can find it. So anyone have any idea on that? If you want to share something, Srinivas.
Yeah, usually the way how we know that the code is already optimized is one of the technique is to see the like how much time it is taking to execute the code, like code execution time, and also like memory usage. These things like tell us whether our code is optimized or not.
Actually, there are some tools also when you are running your code, right? If you are parallelly run that tools, that can tell you the which part of the code is taking more time, that and memory space also. That also we can find it. But I am not currently I forgot the tool's name, but if I will find it, I will let you know.
Yeah, I mean there are tools like JetBrains, resharper tools like dot trace, dot memory. there are the more related to JetBrains. So we can use those tools, but it's kind of licensed. But we can use those tools to just run the profiler and check where the memory leakages are.
Correct.
Generally, yeah, we do use that. And while developing the code, we can use the Sonar scanner. I mean, Sonar Cube is for once you deploy the code or once you develop the code, we use the Sonar Cube to check for any kind of code complexity. But while we are developing the code, there is a NuGet package called Sonar Scanner. So we can use that tool while developing the code itself. It will let us know if there is any kind of code improvisation. If there is anything like that, it will let us know.
We have one
Yeah.
session on that, Srinivas, because tools we need to tell that, because that will be useful for us. We will have one session on.
Sure.
Srikanth, what do you think?
Yeah, yes. Actually, we used to use ReSharper in Deloitte projects. I used to add it along with Visual Studio, and we used to use it while developing. So SonarCube is another one. Yeah, I think we can have one session to explain everyone like how to use these tools and the purpose of these tools, using these tools, how we are optimizing the code and all.
Sure.
Yeah, I think it's a very good idea, actually.